Hi, so in this video, I'm going to be talking about the interview question, continuous median of a stream of numbers. Okay, so let's just recap a little what a median is. For example, you are given some numbers in this container. If you are given some numbers like 1, 5, 3, 2, and maybe 4. So what you have to do to find the median is basically sort these numbers, right? Sort these group of numbers. So they come out to be 1, 2, 3, 4, and 5. And then pick the middle one. Pick the middle one, right? So I'm going to pick the middle one. So my middle number is basically 3 and the median for this one is 3, right? As simple as that. Now consider a stream of numbers like, not really a stream of numbers as of now. I'll explain what stream of numbers means. So let's just consider another set of numbers like 1, maybe 3, 2, and let's consider 4. Okay, then again we have to sort these. If it's already sorted, then there's no need to sort, but as you can see, that's not sorted. So I'll sort, and after sorting it comes out to be this, right? This is the orientation after sorting. So again I have to pick the middle one, but in this case we had odd number of elements, so I could pick the middle one as 3. It's as simple as that. But how do I pick the middle one here, right? So how do I pick the middle one here? It's as simple as that. Pick the kind of, if this is the middle, right? And there is no number in there, I'll just pick the leftmost and the rightmost number and add them. So 2 plus 3 by 2, which is 5 by 2, and 2.5 will be my answer, right? Consider another case where I have numbers like 10, 11, maybe 13, and maybe 14. I think these numbers are sorted. Again, if I have to find the median, again I'll just add these two. So 11 plus 13, which is around 11, 13. 13 plus 10 is around 23, 24, right? So 24 by 2 is going to be 12, and 12 is the median, right? I hope I am not wrong here with the calculations. Yeah. So 24 by 2, which is 12, is the median here, right? So let's just understand what the stream of numbers means, right? So in the input, right, in the input you will be given an array, right? Array or a stream of numbers. So for example, if the array looks like this, 1, 5, 10, maybe 20, 30, and 2. Okay, so it's not stated that you have to be given the entire array elements all at once. In fact, in your input you have to process these elements one by one, right? So for example, my answer will be definitely an array of median, right? So my answer will be an array of median. So my median array, right, my median array is going to be looking like what? Let's see. So I have to compute median for each and every instance, right? So there are 1, 2, 3, 4, 5, 6. So I have to compute 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I have to be computing 6 medians. Let's see how. So at first, my container, right? My container looks like this. At first, I have one element, right? I have one element. I won't take all the numbers at once. That's wrong. I'm taking a stream of numbers. One by one numbers are coming in. Okay. So at first 1 comes. Now what is the median? Median is basically the middle element, which is 1. So my answer is 1. Not an issue. Now 5 comes. Okay. 5 comes. So what is the median as of now? Again, I told that if there is no middle element existing, I'll take the leftmost and rightmost and then add them and divide by 2. So basically I'll be having 1 plus 5, which is 6 by 2, which is 3, right? Now I'll have 10 here. Okay, I'll have 10. So again, now I want to find the median. Again, this is a stream of numbers. This is a stream and not an entirety of the number, right? So one by one the numbers are coming into the this container, one by one, and I have to find the elements. I mean, I have to find the median here, right? I hope you are getting the point. So again, 1, 5, and 10. What is the median? It's the middle element, which is 5. I'm happy with this. So 1, 5, 10 are in the container as of now. Let's see 20, right? So 20 comes in here. Again, this is the entire thing is sorted. How do I compute the median? Again, 5 plus 10, which is 15 by 2. So 7.5 will be the median when 20 comes in. Let's talk about 30. Okay. So 30 comes up here. Again, I have to check, is this sorted? Yes, it is sorted. Again, I have to take the I have to take the median. So I think the median is the middle element, which is 10 here, right? So 10 kind of falls completely in the middle of the entirety. So 10 comes up here, right? So when 30 comes in, 10 is the median. What happens when 2 comes in, right? So can I just add 2 up here? No, I have to be adding the 2 in a sorted position, okay? So how do I do that? Well, 2 comes up here. So as of now, I write this as 2. I sort this. In the earlier stages, up till here, the elements were sorted, so I had an advantage. But in the question, all the numbers won't be really sorted. You have to be kind of sorting them. But here's the key point. I'll just explain that in a moment. So 2 comes in. I have to again sort this. So 1, 2, 5, 10, 20, and 30. Now find the median. Well, I can see there is no such thing a middle element, right? So leftmost and rightmost. So 5 plus 10, which is 15 by 2, which is 7.5. So my 7.5 is the median when 2 comes in, right? And this is the entire output I should be getting, right? Again, see, I'm not telling you to find the median of this entire array, right? Then you would have just sorted this and then find the median, right? But I'm telling you to find the median as 1 by 1 elements are coming into the container, right? So 1 by 1 elements are contained. So at first 1 came, 5 came, 10 came, 20, 30, and then 2. And then at each point, you have to find the median. Well, what is the very naive approach or the basic approach which comes to even my mind, right? So even in your mind, it might have just popped up, right? So for example, the stream, let me just write it as stream. So it sounds more interesting. So for example, I have stream 10, 1, 3, 5, maybe 20, right? So what will be your initial approach, the initial instinct? My initial instinct will be to take the number, right? So I'll just take the number 10 and I'll sort this. So again, it's 10 and my median out of when 10 comes in, my median is, so this is my median column. Just imagine this is my median column. So my median comes out to be 10 as of now. So this is the first number which came in the stream. Now 1 comes in, right? So 10 comma 1. Again, I have to sort this. So this is 1 and 10. Median will be 1 plus 10, 11 by 2, which is 5.5. Okay. Now 3 comes in. So this will be 10, 1 and 3. And maybe I can just sort this again. So this should be, okay, my bad. I'll just erase this and write this properly. So 1, 3 and 10. Okay. What is the median as of now? It's 3 because it's the middle element, right? I think we are done with 10, 1 and 3. Basically 5 is left. So 10, 1, 3 and 5. So again, I have to sort this, right? I have to sort this again. So this is going to be 1, 3, 5 and 10. What will be the median? 3 plus 5 by 2. I think that's 3 plus 5 is 8. 8 by 2 is 4. Yeah, so 4 is the median. I think we will have 20, the last element. So 10, 1, 3, 5 and 20. And again, I'll just sort this, right? I'll just sort this. And this is going to be 1, 3, 5, 10 and 20. Well, what is the middle element as of now? I think it's 5. So my 5 is the answer, right? It's as simple as that, right? What is the time complexity of this? Let's just figure it out. So you can see here that I'm accessing each and every element. So for example, the length of the stream is n, right? So for each and every element n, I'm sorting it, right? I'm sorting the existing container. As of now, these are the containers, right? So I'm sorting these containers, and the optimal sorting algorithm takes n log n time complexity, okay? So inside, so I'm just going to write it like this so it's more clear. I'm going to draw a for loop here. So I'm looping, okay, so I'm looping through the stream once, right? So I'm looping stream which is of length n, right? And for each number I am sorting, right? So I'm sorting for each number. So that's I think that's n log n, right? So what is the overall time complexity? I think it's clearly visible as of now. So the overall time complexity is n multiplied by n log n. So big O of this thing. So this comes out to be big O of n square log n. And that's actually huge for maybe like if n is basically 10 to the power 5, then this will be really huge, right? I mean, the log n part will be less, but the n square part is going to be problematic for us, right? So how do I optimize this, right? This is the naive approach, but how do I optimize this? Again, if you are concerned about finding the median, well, you can just do that. You can check that if container size, right? If container size is odd, then pick middle element, right? Or if the container size is even, then you know the drill, right? You have to just pick the, for example, if the middle element was going to fall up here, so you're gonna pick the leftmost part and the rightmost part, and then add up those two and divide by 2. So L plus R by 2, as simple as that, right? So how do I optimize this, right? How do I optimize this problem statement, stream of numbers, and I have to find the continuous median? And again, up here, I'm going to be using the concept of heaps, right? And most probably Minheap and Maxheap, okay? So I'll just take this same example just so that we are on the same page. So 10, 1, 3, 5, 20, okay? 10, 1, 3, 5, 20. Okay, I'll just take the stream up here. So stream. So I think it's 10, 1, 3, 5, and 20, right? And I hope it's still recording. Yeah, it's still on the recording process. So I'm going to be making use of the Minheap and Maxheap concept. And how do I learn that? Well, you can go back to my channel, or if you're watching this video as of now, so you can just click on the channel and then you can find the videos. I have made 2 videos on Minheap, right? On Minheap, and there are 2 separate videos to be more precise. The first one is an intensive video explaining the logic in as simple terms as possible, and then the other one is code. Again, both of them I have explained in as simple words as possible, okay? So a prerequisite to this video has to be learning the Minheap concept, right? The one which I explained just as of now was the naive approach, right? Sorting part and so on. So how do I do that? Well, I'll just make use of 2 parts. I'll just divide this into 2 parts, okay? I'll just divide this into 2 parts. At first, I'll have Maxheap. Okay, I'll have Maxheap, and then up here I can have Minheap. Okay, so I'll first have Maxheap and then I'll have Minheap. Okay, or it might be the other way around. It really doesn't matter as of now. So let me just change the colors here. So what is the property of Minheap? I think I don't really need to go into deep about these explanations because again, as I mentioned, this is a prerequisite that you watch the videos. And once you are done, once I start explaining this, you will find it very easier, right? You will find it 10 times easier. But you have to be watching the video of Minheap. Again, you can find this on my channel, okay? So 10, 1, 3, 5, 20. Again, I have to be processing elements one by one, not at once, okay? So let's see. So at first 10 will come, okay? So this is my Maxheap part and this is my Minheap part, okay? So when I have number 10, right? When I have number 10, I'll be actually checking that if my Maxheap is empty, right? I'll be trying to fill up the elements in Maxheap, and then I'll be trying to fill up the elements in Minheap, and you will just get what I'm trying to say. So 10, right? So I'm seeing that Maxheap and Minheap is both empty, but I could have filled 10 up here or 10 up here. It's my choice. But again, as I mentioned, I'll just try to fill up Maxheap first and then Minheap. So I'm prioritizing Maxheap as of now. So I can just write 10 here, right? I can just write 10 here. It's as simple as that, okay? Now, there's a small condition here that if the length of the Maxheap, right? As of now, the length is 1, right? And the length of the Minheap, which is 0. If the length of the Maxheap is greater than the length of the Minheap, okay? And basically the absolute difference between the length is not 2, right? So this is the condition that if the length of Maxheap, so I'm just going to write mx Maxheap minus length of the Minheap, right? So Minheap MNIH is equal to 1, okay? So if if it's equal to 1, which means that max heap has one more element than min heap, right? Then my answer will be the topmost element in max heap. Okay. Now again, one condition arises. If my length of the min heap minus length of the max heap is 1, then my answer will be topmost element of min heap. Okay, I'll just write topmost element of min heap. But what if any of these two results in not equal to 1 but equal to 2, right? Then I have to rebalance. In case the absolute difference between these two are basically greater than equal to 2, right? I have to rebalance. One more condition arises, that what if the absolute difference between these two is 0, which means the length of both of these are equal, right? Then my answer will be as simple as topmost elements from those two, right? So topmost element from max heap and min heap by 2, right? So let's just figure it out. It's not very complicated as of now, so you will understand as we go. I'll explain this example and one more example, right? So that you are on the same page. So max heap, right? So I put element 10. Okay. Now answer will be what? As I mentioned, that since max heap is greater than min heap, right? The length of the max heap is greater than the length of the min heap. My answer is simply 10, right? So I'll just have a median answer here. So maybe I can scroll up here a little. I'll write median, and my median is going to be containing 1, 2, 3, 4, 5. So my 10 is the first answer. That's 1, 2, 3, 4, 5, right? Let's just get started with the other one. So it's 1 here, right? It's 1 written here. So how do I balance this? I mean, where do I enter this, right? So I'll check that if 1, right? If 1 is smaller than the topmost element of max heap, then I'll just put it into max heap. Else, if the number, so 1 is what? 1 is the next number, right? So I'll just say it like this. If the number which I'm putting in next, right, is actually less than the topmost element of max heap, right? So if it's less than the topmost element of the max heap, which is 10, then I'll put it here. Else, I'll put it in min heap. Okay. So I hope that makes sense. So let's just get started. So 1, is 1 less than the topmost element of max heap, which is 10? Yes, it is. So I'll just put it up here, and it's satisfying the max heap property. Okay. Again, you can just watch the prerequisite videos as I mentioned. So what is basically the median here, right? Now remember what I said, that the length of the max heap is 2, length of min heap is 0. So again, check here what it's saying. It's saying that if the length of max heap minus length of min heap, if any one of these two, this is the first condition, this is the second condition, if any one of these two comes out to be 2, right? And in this case it is, right? So length of max heap minus length of min heap is 2. So 2 minus 0 is equal to 2. Then what do I need to do? Let's just see what do I need to do. It's saying that rebalance, right? It's saying rebalance. How do I rebalance? It's as simple as this. So notice the procedure. I'm going to be taking the topmost element of basically max heap and inserting it into the min heap. Okay, I'm taking the topmost element of max heap and going to be inserting it into the min heap. Okay, so now check. What I'm going to do is basically remove the topmost element, which is 10 here, okay, and place it into the min heap. And what is this one going to be doing? So again, I'm just going to remove this one and rebalance it, or maybe like shift up. Again, you will understand this in the prerequisite videos. I'm going to shift up. So 1 and 10. Now I'm good to go. Now, what is it saying? The conditions that, again, I mentioned that if both of the lengths are equal, I'll just take the topmost elements in both of them, right? And then add them and divide by 2. So 1 plus 10, which is 11, and 11 by 2 is basically 5.5. So as of now, my answer is 5.5. As simple as that. Okay. Let's consider the next element, which is like 3, right? So I'm going to check 3, right? So is 3 less than the topmost element of max heap? If it's less than Maxheap, topmost element of Maxheap, I'll put it in Maxheap. So is 3 less than the topmost element 1? No. So I'll just put it in here, right? So I'm going to put 3 here. And again, this is not following the property of Minheap. So I have to readjust this. That's not an issue. So this is going to be readjusted as following. So 3 and 10, right? Now, again, I have to be checking one condition here. What is the length of Maxheap? It's 1. What is the length of Minheap? It's 2. So 1 minus 2 is, or maybe you can consider this as 2 minus 1 is 1. Absolute is 1, right? And again, what did I say? That if it's 1, right? If it's 1, so length of Minheap, right? So length of Minheap, which is 2, minus length of Maxheap, which is 1, then topmost Minheap element is the answer, right? So in this case, the topmost of Minheap is 3, and 3 is going to be my answer, or the median. So my answer as of now is 3, right? It's as simple as that. I'll explain another example. That's not an issue. I'll take 40-50 minutes, whatever the case may be. So 5, right? Again, I'm going to check with the Maxheap topmost element. Is 5 less than 1? No, it won't be really coming here. So is 5, so 5 is definitely going to be going to the Minheap, right? So 5 comes up here. And again, this is following the property of Minheap. That's not an issue at my end, okay? So again, I'm checking that length of Maxheap is 1. Length of Minheap is basically, so I'll take absolute. Length of Minheap is 3. So what is the absolute? 2. So again, once I have 2, I have to rebalance. And again, how did I rebalance when I had 2 elements in Maxheap and 0 elements in Minheap? I just removed 1 from Minheap and pushed it into the Maxheap. So what should I be removing? Well, I'll be removing the topmost element, which is 3. So I'll just remove 3 from here and push it into the Maxheap, right? And again, restructuring of these elements are yet to be done. So how do I do that? Again, these operations are discussed in the videos. So Maxheap will be replaced like this. So 3 comes up and 1 is down below. And for this one, it's as simple as 5 comes up here and goes from here. Okay. So again, the length of both of these, right, are equal. So what will be my answer? Answer will be the topmost element of both of these by 2. So 3 plus 5, which is 4. 3 plus 5 is 8. So 8 by 2 is 4. So as of now, my answer turns out to be 4, right? As simple as that. Let's just consider the last element, 20. Is 20 less than the topmost element of Maxheap? No, it is not. So basically, if it's not less than 3, then I'll just put it into Minheap. So 20 comes up here. And again, the entire thing is following its properties. Now, again, you can see here that the length of Minheap is 3 and length of Maxheap is basically 2. So the absolute is basically 1. Now I'll check that if the Minheap's length is greater than the Maxheap and the absolute is 1, I'll pick the topmost element of Minheap. So that's 5. As of now, my answer turns out to be 5. And let's just verify the median, which we kind of figured out from these explanations. So 10, 5.5, 3, 4, and 5. Okay. So this is what we got here as well. 10, 5.5, 3, 4, and 5. And this was the naive approach. This was basically n square log n approach. But this is more efficient. And again, time complexity, I'll be explaining. So 10, 5.5, 3, 4, and 5. Right? As simple as that. Let's just take one complex example. Maybe like I'll take stream. And the numbers are going to be maybe 10, 15, maybe 5, 20, and 25. Right? Okay. We're good to go. So now I'll be dividing this into 2 parts, right? Again, this will be Maxheap and this will be Minheap. Okay. Let's get started. So 10, right? There is nothing, both of these are empty, right? So what should I be doing? I should be just simply putting in 10. So I'll just write median, which is going to be my answer. Yeah, this looks good. So 10 comes up here. That's fine. What will be the median? Median will be basically 10 as of now, right? Okay, get started with 15. Is 15 less than the topmost element of Maxheap? No. So I'll just add 15 here. Length of both of these are equal. So pick the topmost element in both of them. So 10 plus 15, 25 by 2 is 12.5. As fine as that. Now take 5. Is 5 less than the topmost element of Maxheap? Yes, it is. So I'll just put 5 here. Length of Maxheap is 2. Length of Minheap is 1. So 2 minus 1 is 1. But Maxheap is having the advantage because it's having 2 elements. So I'll pick the topmost element of Maxheap instead of the Minheap. So my answer is 10 when 5 comes in. When 20 comes in, is 20 less than the topmost element in 10? Topmost element in Maxheap, which is 10? No. So I'll just put 20 here. As simple as that. Now, what will be my answer? Well, I can see here that both of these lengths are equal. So again, I'll just pick the topmost elements and add them and divide them by 2. So 10 plus 15, 25 by 2 is 12.5. Okay. Pick 25. Is 25 less than the topmost element in Maxheap? No, it is not. So I'll put it in Minheap. Okay. So again, what is the orientation of lengths? So length of Minheap is 3, length of Maxheap is 2. So 3 minus 2 is 1, but Minheap is having advantage of the length, right? So 3 minus 2 is 1. This is having the advantage. I'll pick the topmost element, which is 15, and my answer is 15. Okay. Let's just cross verify, kind of like cross verify if we are right or not. So 10, 15, 5, 20, 25. Okay. So I'll just write it in here. 10, 15, 5, 20, 25, right? So at first 10 comes in, so median is 10, that's fine. 15 comes in, right? So this is going to be, I'll just write it like this. So now 15 comes in, right? So 10 plus 15 is 25 by 2 is 12.5, that's right. 5 comes in, so 5 will be basically up here. It's going to be sorted, right? So I think I made a little mistake. So this should be 5, 10 and 15. What will be the median? It's the middle element, 10, right? I'm good on my half. 20 comes in, right? So 20 comes in. So again, 20 will be simply in a sorted order. This will be coming after 15. So what will be the median? 10 plus 15, 10 plus 15 by 2. 25 by 2 is 12.5. Again, I'm right. Let's consider 25, right? So 25 is going to be coming up here in a sorted manner. And what will be the median? Well, I can see the median is the middle element 15. And again, 15 is right. Okay. So let's get started with the implementation part or the coding part, right? And how will I be doing that? Let's see. So again, the Minheap construction video with proper comments, right, in the Python code I've written. So the Minheap construction video I have already explained and it's already out, and I encourage you to watch that before watching the code of this video, because I'm going to be simply copying the entire orientation or the class of Minheap and then pasting it over the continuous median class. Okay. So let's just define some class called continuous median, because that's where the magic is going to happen. Okay. So maybe like my stream of numbers is given as maybe like, let's just get started with the simpler one. 1, 2, 3, 4, 5, 6. I'll go with the complex ones as well. That's not an issue. So stream of numbers, oh my bad. So this should be numbers is given. I'll create one class, but in a moment, I'll just want to have the Minheap class as well here. So I'll just copy this, right? I'll just copy this and maybe like, yeah, I'm done with this. So Control C, Control V, that's what we do all the day. So I'll just copy this entire thing. And again, I'll be introducing some very few concepts here. So Minheap has been created, right? I'll just introduce or add one small feature. Length, right? My length will be added, and what will be the length containing? It will be containing the length of the self.heap method, okay, or maybe the heap, right, and not the method. So length of self.heap, right? As simple as that. Now notice that when we are adding here, right, when we are inserting any element into the Minheap, I'm increasing the length here. So self.length plus equal to 1, right? That's an increment operator. And when I'm removing anything, I'm actually decreasing it, right? So self.length minus equal to 1. As simple as that. Now, I want to be making a class of Maxheap as well, right? I want to be making a class of Maxheap as well. How do I do that? I'll just copy this. It's as simple as that. It's similar to Minheap. It's not really complicated. So I'll just rename this as Maxheap, okay? I'll just rename this to Maxheap. I hope it's being recorded. Yeah. So Maxheap has been renamed, and what will be the changes here? So again, I've discussed this in the previous video or the Minheap construction video, the logic part and the code part as well, that in Minheap we are checking with the less than operator, right? But in the Maxheap, I'll be just replacing that with the greater symbol operator. Okay. or maybe the greater than sign operator. Okay, and I hope it's clear at your end. So here we are in the Minheap class, or the Maxheap class to be more precise. Okay, I'll be just replacing these symbols, right? So this will be greater than. Again up here, this will be greater than, and I think there will be no more changes due. Yeah, we are good to go, right? So only the name is something I changed here, the Maxheap, right? And I changed these symbols. And again, this is something which I added. So self.length, I added in the Minheap and Maxheap as well. Okay. So now that I have Minheap and Maxheap classes, right? Now I have, so I'll just write, now I have Minheap and Maxheap classes. So I don't need to worry about them. Okay. I could have written the entire thing from scratch, but that would have taken the video to past 1 hour. So I don't want to repeat what I have already explained with beautiful comments in the previous video. Okay. So now I have the Minheap and Maxheap classes. I want to make a class of like continuous median, right? So maybe like make a class of continuous median, and pardon if I have any spelling mistakes in between. So I'll just write class, maybe like C median, right? So continuous median. Okay. And I'll just write it like this. So define, so what is define init underscore underscore, right? So that's basically a constructor in Python. So self, and you can see here, right? Okay, I think that got removed. So I'll just open up the whiteboard again. So as far as we remember, we had 2 segments here, right? Okay, I'll have to zoom out a little and focus on this part. Yeah. So as far as I remember, we had 2 segments, Maxheap and Minheap, right? So again, Maxheap and Minheap. So should I be naming that as Maxheap and Minheap? I mean, I can just rename it as first and second, right? So this is the first part. I'll just write it like this. So this is the first part, right? This is the first part, and this is the second part. Okay. So first part is going to be having Maxheap, second part is going to be having Minheap. Okay. As simple as that. So my self.first, right? So self.first is going to be what? Let's see. The first self.first is Maxheap, right? So I'll just write Maxheap class, and I'll be initializing an empty array inside of it. And again, self.second will be having Minheap. And how I'm writing that? Again, we have seen in the explanation, but I'm just considering second as Minheap. Okay. So Minheap, and I'll be having the empty array up here. And again, I'll be having one variable called median. That will be my answer. So median is basically none, because when I have nothing at the beginning, when I have no number in the stream, then my median is nothing, right? So it's good to be 0. I won't really write 0 because 0 is also a number. So I'll just write none, or maybe I can write false, right? It doesn't matter. So I will just go with none. So what will be my functionalities of the class median? I can insert elements, right? So insert elements in median 1 by 1, right? So let's just define that class. So define insert, right? Self comma number, right? The number from the array. So the number, not from the array, number from the stream of numbers, right? So how do I insert that? I think it's not really a complex process. Let me just think. So I'll check that. Okay, let's just pass this as of now. I'll get back to this. What else can be the classes? So insert elements in median 1 by 1, that has been done. Okay, I have to be rebalancing, right? So rebalance the heaps, right? When we have the absolute difference of lengths equal to 2, right? When absolute difference of lengths is 2, then rebalance, right? So this is going to be a class called a method called rebalance heaps, right? So rebalance heaps, and that makes sense. Self, and then I'll just pass this as well. I just want to be having all the methods in my mind clear. So after this, I'll be having update median, right? So my median is also going to be updated. So update median method to update the new median. Okay. So this is going to be as simple as define update median. Okay, and this is going to be self. I'm just going to be passing this, and maybe I'll have a method called return median, which is going to be returning me the answer. So define return underscore median, and this is self, and let's just complete this as of now. So this is going to be return self dot median. Yeah, I think that's good to go. Yeah. Let's see if I am missing on any classes or methods here. I think I'm good to go with the class. So I'll just create a class object here. So obj, maybe like obj and c median, right? So this is my class as of now. Obj c median, and for number in stream of numbers, right, I'll be inserting that number into the object or the class median, right? So I'll be writing obj dot insert, right, because that's what I'm doing, number, right? So I'm inserting the number, and then I'll be printing the median as well. So obj dot return median, right? And I hope that makes sense. So obj dot return median, and then I'll want it to be printed on the same line as possible. Okay, yeah, that's good to go. I think we are done with the below part. I think we are good to go with the Maxheap and Minheap. Let's just figure it out. I mean, I'm writing the code after a lot of time, but let's just figure it out. So insert, right, where I'm going to be inserting the number. Okay, let's see. So what did I say? That if both of them are empty, I'll be preferring Maxheap, right? That's what I mentioned. I mentioned that I'll be preferring Maxheap when both are empty. When both were empty, I will prefer Maxheap. So how do I do that? Maxheap is first, right? So I'll just check that. If not, basically self, or maybe I'll just write a self dot first dot length, and this is where the length feature comes into play, right? You might be wondering why I mentioned length here. This is why the length feature comes into play. Okay, so if the length of the first, right, so if the self dot not self dot first dot length, so if it's empty, or the number which I am inserting into the stream is less than the basically these topmost element of the first part, right? That's what I mentioned, the topmost element of the Maxheap part. If the number is less than the topmost element of the Maxheap part, I'll insert that into the Maxheap, right, or the first part. So self dot first dot peek the top element, right, because that's going to be returning me the top element here. So if not self dot first dot length, or the number which I'm inserting is less than the topmost element of the Maxheap or the first part, I am going to be simply relaxing and inserting into the first part the number, which is basically number, right? Else I'm going to be doing what? I'm going to be inserting it into the second part. So second dot insert. That's the beauty here. You don't have to be checking again and again. You just have a if condition, lengthy if condition, and then an else condition, right? And I'm going to be inserting this number. As simple as that. Now that I've inserted the number, I have to rebalance, right? So I can just call self dot rebalance. That's my helper method. And then I'll just call self dot update median, because that's going to be updating my median here, right? Okay, I think I'm good to go. Now that I'm done, maybe like we can start with rebalance or maybe update median. Let me just figure out. So rebalance is going to be rebalancing the heaps, right? Let me just get started with this. So what I really want is that I want to check that if the length of the first half is greater than the length of the second half by 2, then I'll be inserting one element from first half to the second half to balance it, right? So if the length, so self dot first dot length minus self dot second dot length, right? So I'll just put all of these in brackets. It looks more clear and precise. Is equal to 2, right? Is equal to 2, or maybe like greater than equal to 2, right? If it's this, if it's this the case, right, then I'll just write self dot second dot insert, because see what's happening really is, again I've mentioned this, that I'll explain this here. Is it still recording? Yeah, it is. So okay, so this was the first half. Just consider that this is my first half, this is my first, and maybe this is my second, right? And these are some elements, so maybe I can represent elements with star, Okay, so for example, there are 4 elements and up here there are only 2 elements. So I want to see that if the length of the first half, which is 4, is minus second length, or the length of the second half is 2, is greater than or equal to 2. Yes, it is. So 4 minus 2 is greater than or equal to 2. So I'll just put one element from first to second. So afterwards, this will look like this, right? Kind of gets balanced here, right? And it's very interesting, right? So again, I'll just write here that insert what? Self dot first dot remove, right? So the first element, the element from first which will be removed is going to be inserted where? Into the second part. As simple as that. Okay. Elif, I'll check that self dot second dot length minus self dot maybe like the first dot length is greater than or equal to 2, right? So I'm saying that my second half is having maybe like 5 elements and this is having 3 elements. So 5 minus 3 is greater than or equal to 2, right? So I'll be removing one element from second and adding it to first. So again, it's balanced. So how do I do that? I just repeat the process but in a reversed way. So self dot first, I'll be inserting into first. So first dot insert. What will I be inserting? I'll be inserting the element I've removed from the second part. So second dot remove, right? It's as simple as that. No drama and nothing else. Okay. Now that I'm done with this, I'll just delete this multi-line comment which I made for your clear explanation. I maybe can start with the update median. I think if I miss any part here, we can see that in the answer. If the answer comes out to be wrong, I'll just update this if anything is required. Okay. As of now, it looks good. So update median, how do I do that? Let's see. So I want to update the median. My condition says that if, okay, so if the self dot first dot length minus self dot second dot length, right? So I'll just put it in the brackets, is equal to 1, right? Then in that case, well, what I'm doing really, I'll just explain that again. So in the first part, suppose the elements are 3 in number, and in the second part, the elements are maybe 2 in number, right? So I'm saying that the first length minus the second length, which is 3 minus 2, is 1. Then I'll pick the topmost element in the first part, right? That's what my answer should be. So I'll just write self dot median, because this is the method where I'm updating the median. So self dot median is going to be equal to self dot first dot peak the top element, and that's going to be my answer. I'll check that elif. I think I should just copy this to save time. I'll just write this again, and I will just paste that again, and I'm checking that if the self dot second dot length minus self dot first dot length is equal to 1, then my self dot median is going to be self dot second dot peak the top element, right? So again, if the elements in first is basically maybe 2 and elements in second is 3, so I can see that length of second half minus the length of first half, which is 3 minus 2 is 1. Then my median is basically the topmost element of second half, right? Which is the topmost element of the min heap part, right? I hope that's making sense. And what if both of these conditions does not satisfy? Then we are left with one and only one condition, that self dot median will be basically self dot first dot peak top element plus self dot second dot peak top element by 2. So for example, I had maybe like in this case I had 5 elements, and in this case too I had 5 elements, right? I'll just adjust this again. Yeah. So if the length of both of these are equal, that's what this last else condition is checking for. If both of them are equal, then definitely I have to be taking the topmost elements of both the halves and then dividing it by 2. Adding them up and then dividing it by 2, right? And this is it. Define update median has been also done. So let's just try to dry run the code, or maybe like try to execute the code here and see if we are wrong somewhere. I hope we are wrong somewhere so that I can correct my mistakes. So I'm just going to write Python. Okay, before even running the code, I want to analyze what my output will be. So for this one, my output should be what? At first 1 is coming, so 1 will be printed. Then 2 is coming, so 1 plus 2 is 3 by 2 is 1.5. Then 2 will be the answer. Yeah, it is. Then 4, so 2.5 will be the answer. Then maybe like 5 comes in, so 3 is the answer. 6 comes in, so 1, 2, 3, 4, 5. 6 comes in, then answer is going to be 3.5. Round about that, right? Let's see. So I'll just write Python continuous median.py, and the answer is kind of in integer format, right? Let's see where I have messed up. Okay, so in the update median, I think I have messed up. So self.median is the topmost element. That's not an issue. The topmost element. Median is this plus. Okay, so up here I have, what I have done here is, okay, I'll just explain. So what this division and what this division does. So this division is basically known as integer division in Python. And again, pardon for my spelling mistakes. And this is known as the basically the regular one, right? Which kind of gives us floating value or the decimal value if required. So regular one. So again, if I've done integer division here, right, then that's an issue. So that's why I have to use the regular one. So I'll just write again. So Python continuous median.py. I think I should be separating these with some spaces so that it looks good. So I'll just write comma, right, and just write this. So 1, 1.5, 2, 2.5, 3, and then 3.5. That's it, right? Let's just consider one example from our test case. So maybe 10, 15, 5, 20, 25, right? So 10, I'll just write 10, 15, 5, 20, and 25, right? As simple as that. Let's see, 10, 15, 5, 20, 25. What is the answer here? The answer is, I'll just try to highlight my best as possible. So this is the answer, right? 10, okay, this is very bad. 10, 20, 10, 12.5, 10, 12.5, and 15. Okay, let's see. So I'll just remove this because that's something which we have figured out from the explanation on whiteboard. So 10, 12.5, 10, 12.5, and 15. So you can see here, it's 10, 12.5, 10, 12.5, and 15. And that's how you execute or make up this class, or that's how you are going to be running, doing this entire thing. Okay. And as far as the time complexity is concerned, I want you to maybe like do a research on your own. What will be really the time complexity? Because the reason I'm saying is that in Minheap construction, I've explained the time complexity, right? I think I've even written in the description as well for the Minheap. I'll be surely writing it in the continuous median as well in the description section. But I want you to figure it out on your own first and then look at the description, right? So that will kind of improve your logic building for time complexities and space complexities as well, right? So the only takeaway from this is that you have to be practicing this quite often. And one small task or homework, I'm not a teacher, right? I'm just a regular person writing codes. So I want you to do is figure out the time complexity on your own. One small optimization you can do is, instead of creating two classes, right? So one Minheap class and one Maxheap class, you can just create one class. So you can just basically create one class Heap and proceed with the logic, right? The logic will be the same. So you can just create one class Heap and then kind of figure out on your own how to divide that class into Maxheap and Minheap. Because if you use only one class Heap, then you have to be separating operations for Maxheap and Minheap, right? Because we have two data structures we are using here, right? So that's the second part you have to do. So this is the first part was basically, I'll just write it again. So the first part is figure out the time complexity and space complexity, right? So figure out the time complexity and space complexity. Second one is create one class Heap and proceed with the logic. That's it. And again, the time complexity and space complexity will be given in description, right? I can simply explain that. That's not an issue at my end. but I want you to kind of figure it out. And that's going to be the best part of it, right? So I hope the entire video made sense and my explanation was clear, and maybe we can meet in the next video with another explanation on a random interview topic. Okay, thank you.